All right, guys. So we're going to go on to lesson two. And what we're really going to focus on in this section is units and unit conversion and prefixes and some of the math that we have to deal with when we're trying to communicate data with other scientists. So the first thing that we're going to talk about is standardized units and why we need them. So a standard is an exact quantity that people agree to use to compare measurements. And what's important to realize is these standards, like the length of a meter, how big is a meter, or how hot is 100 degrees Celsius. These standards were invented by humans. They're not part of nature. They're a construct from humans that we use to help clearly communicate to each other. And the reason is this. Let's say that you and a friend want to measure something like the width of your desk. You want to make sure that you can fit the desk out the door because you're trying to move it. But you don't have a ruler, so you decide to use your hands. And you determine that the desk is so many times the width of your hands. Maybe you can fit your hands across the desk 15 and a half times. And then your friend measures the width of the doorway with their hands. The problem with this is that you and your friend's hands probably aren't the same width, and so you're not going to be able to get a very good comparison about whether or not these things are going to fit with each other. Or another situation would be, what if you measure the distance that you run by the length of each of your feet? So here, the situation again presents a problem, because if your feet are longer than your friends, then you might communicate to them that you ran less feet than them, but in actuality, you may have run the same distance. So we need a standardized unit so that we can communicate clear with each other. The other thing is that we actually need units. Let's say that you label a length of string just 150. Your friend or someone else might not know if that means that the string is 150 feet or 150 meters, which is over 3 times as long, or 150 centimeters, which isn't going to be very long at all. And there are real-world examples of where this has been a problem. So in our country, we don't typically use SI units. We don't use things like meters and centimeters. We usually use feet and inches. Well, scientists at NASA were working on a project for a mission that was supposed to go to Mars. And the scientists working at NASA were using one set of units, while the scientists collaborating with NASA all around the world were using a different set of units. And it wasn't until they launched the rover that was going to Mars that they realized that they had not converted everything to the same units. So when the rover was supposed to land gently on the surface of Mars, they had miscalculated because they hadn't all used the same units, and it smashed into the surface of Mars and was destroyed. So very, very important for us to be communicating and telling each other what units we're using so that we're all on the same page. So a system was developed called the International System of Units. It's called the SI standard. And an example of this would be the kilogram. So the SI standard unit for mass is the kilogram. And a kilogram cylinder of metal is kept in France, and all other kilograms are compared to that kilogram to make sure that everyone is representing a kilogram of mass as the same amount. So here's a chart of units. The standard unit of length is the meter. The standard unit of mass is the kilogram. The standard unit of time is the second. The standard unit of electric current is the ampere. And these are the symbols that we would use for the shorthand of that. The standard unit for temperature is Kelvin. The standard unit for the amount of a substance is the mole, and we're going to use that a lot in chemistry. And the standard unit for the intensity of light is the candela. And you might recognize that word because that is the name of the leader of the Valor team in Pokemon Go. Why do you think they gave her that name? Another thing that you might notice is that of all of these units, only one of them has a prefix, and that's the kilogram. So it's important for us to remember that the standard SI unit for mass is not a gram. And that's because a gram is too small a unit. Everything that we measured would be lots of grams because a gram is about the same as the mass of a Post-it note. So not a whole lot. So we use a unit 1,000 times bigger than that as our base unit. All the other ones have no prefix, but the mass does. Our standard unit is a kilogram. So that's really important to remember. So here's a chart that will show you the prefixes that I want you guys to know. So kilo, the prefix kilo in front of any unit means 1,000. So as an example, 1 kilometer is the same as 1,000 meters. And we might write this instead as 1 km equals 1,000 m if we were using these symbols instead. Deci means 1/10. Centi means 1/100th. Milli means 1/1000th. Micro means 1 millionth, and nano means 1/1,000,000,000th. So we might also decide to put these in scientific notation. So this would be 1 times 10 to the third. This would be 1 times 10 to the negative 1. This would be 1 times 10 to the negative 2. 1 times 10 to the negative 3. 1 times 10 to the negative 6. And 1 times 10 to the negative 9th. And this tells you how far to move the decimal place. This is 1,000 times bigger, so we would move the decimal place 3 places. All of these are powers of 10. Here, this is 1/10, so we would move the decimal place 1 place to make the number bigger or smaller, depending on where we're moving from. We'll talk about that in a second. Let me give you another example. Let's say that we have 105 grams. We could write that as a kilogram. Remember that a kilogram is 1,000 times bigger than a gram. So this isn't 1,000. We would need 1,000 grams to fill 1 kilogram, but we only have 105. What we'll do is we'll move the decimal place over because we'll get a smaller number and we'll end up getting 0.105 kilograms. Let's get some more practice with that. So the question you should be asking yourself is, what's the difference between the two prefixes I'm trying to convert between, and how many places and to what direction do I need to move the decimal? Here's the way you should think of this. Let's go back to the example with length. So let's say I have 532 meters and I want to convert to kilometers. So the first thing that I need to think is a comparison between the numbers. Is my new unit bigger or smaller? My new unit is a bigger unit than before. Because it's a bigger unit, I'm going to end up with a smaller number. Here's a way to think about this. Let's say that the original unit we have is in a cup, and we fill that cup with water. If I want to pour out that water into a new cup, and the new cup is bigger, meaning the new unit is bigger than the old one, the water level won't be as high. Okay, so this is my small unit with a high water level, and this is my large unit with a low water level. So we're expecting a smaller number. Now the nice thing about unit changes is they're never going to change the numbers themselves, they're just changing the decimal place. So because we know a kilo means 1,000 or 10 to the third, that means we're going to move our decimal place 3 places. And we know that our numbers should be smaller, so we're going to move it over 1, 2, 3 places. That's where our decimal should end up. And that's our number. So again, here's a chart with all of the prefixes. Now, I want you guys to know these prefixes. Okay, now if you know pico and mega, that's awesome. But these center 6 are the most often used. What this chart is telling you is that if you go from, let's say we go from a centimeter to a kilometer, we're going to move the decimal place to the left. So the example of that would be, let's say we have 5,000 centimeters. Let me change the color back. And we want to go to kilometers, right? So we know we're going to be moving the decimal place to the left because we're going up the list. We'll move to the left. And we just need to figure out how far away that is on the list. So in this case, we're going from -2 to 3. So let's think about that. So -2 to 3. So here's -2, and then we'd have -1, and then we'd have 0, and 1, and 2, and 3. So this is telling us how far we need to go. We're going to move to the left 1, 2, 3, 4, 5 places. So when we do that, we're going to go 1, 2, 3, 4, 5 places, and we'll get 0.05 kilometers. Let's try another example. Let's say that I have a decigram, and I want to convert it into a milligram. So let's say I have 102 decigrams, and I want to convert it into a milligram. So in this case, I'm going from deci to milli, and let's make another number line again. So we're going from -1 to -2 to -3. So, and we're going down the list, so we're going to move to the right, 1, 2. Okay, so we're going to move it to the right. We're going to go 1, 2, like that. So we should have 100, get 2 extra zeros there, so we've got 10,200 milligrams. Go on to the next video when this is done.